In the next few videos, we're going to improve our understanding of exponents. Let's start with an example. Let's say we have 2 to the third power times 2 to the fourth power. So how could we simplify this? Well, we have a couple operations, so why don't we bring out PEMDAS? And we have exponents and multiplication. So PEMDAS says start with the exponents. So we'll simplify 2 to the third, and then 2 to the fourth, and then PEMDAS says to multiply those two. So 2 to the third power is 2 multiplied 3 times, and then 2 to the fourth power is 2 multiplied 4 times. So we've completed our e, we've simplified the exponents, and now we need to multiply. And if you notice, we're multiplying 2 3 times, and then we're multiplying 2 4 times. So overall, we're multiplying 2 7 times. And we can think about this as 2 to the 3 plus 4 power. 3 plus 4 is 7. So this is our first property. If you're doing multiplication with exponents and you have the same base, that big number, then you just add the exponents. So 2 to the third power times 2 to the fourth power is the same as 2 to the 3 plus 4 power. And that would simplify to 2 to the seventh. So our shortcut here, if we have some number to the m power times that same number to the n power, then we can rewrite this as the number to the m plus n power. So that's what our example showed. We had 2 to the third power times 2 to the fourth power. And this is the same thing as multiplying 2 7 times. So we thought about this as 2 to the 3 plus 4 power. Let's try another example. Let's have 5 to the second power times 5 to the sixth power. So we're multiplying 5 2 times, and then we're multiplying 5 6 times. So we can think about this as multiplying 5 2 plus 6 times. And that would give us 5 to the eighth. All right, let's try a different example. Let's say we have 2 to the third power, and we take all of that to the fourth power. How could we simplify this? Well, to start off, let's think about that 2 to the third as just a box. So inside those parentheses, we just have a box. And we're saying, take the box to the fourth power. Well, box to the fourth power would just be box times box times box times box. And we said our box was 2 to the third, so then we could substitute that back in. So we'd have 2 to the third times 2 to the third 4 times. And we just learned that if we're doing multiplication with exponents and we have the same base, we can add the exponents. So this would simplify to 2 to the 3 plus 3 plus 3 plus 3. And another way to write that would be 2 to the 3 times 4. Both of these give us 12. Adding 3 4 times is the same as 3 times 4. And this gives us our second shortcut. If we raise a number to an exponent, and then raise that to an exponent, we can just multiply the exponents. So from our first step, we can go straight to the last step. So 2 to the third to the fourth power becomes 2 to the 3 times 4 power. So our shortcut here, if we have a number to the mth power, and we take that to the nth power, then we can rewrite it as the number to the m times n power. So we had 2 to the third to the fourth power, and we rewrote that as 2 to the 3 times 4 power. Let's try another example. Let's say we have 7 squared, and we take that to the 5th power. We can think of this as 7 squared multiplied 5 times. And since we're doing multiplication with the same base, we can add the exponents. So we're adding 2 5 times. And we can rewrite this as 7 to the 2 times 5 power. If we used our shortcut, we could have gone from the first step to the last step. And since 2 times 5 is 10, our final answer would be 7 to the 10th power. So these shortcuts allow us to work with exponents a lot faster, but it's important to understand these steps in between, especially when problems get harder. Let's learn one more shortcut. Let's say we have 2 times 6, and we take that to the 3rd power. How could we simplify this? Well, we could think about our 2 times 6 as a box. So we're taking our box to the 3rd power, which means we're multiplying the box 3 times. And since our box represents 2 times 6, we can substitute that in. So our first box is 2 times 6, our second box is 2 times 6, and so is our third box. So we're multiplying these numbers, and we've learned that we can multiply in any order. So we can group our 2's and our 6's. So we can write this as 2 times 2 times 2 times 6 times 6 times 6. And since we're multiplying by 2 3 times, we can write that as 2 to the 3rd power. And we can do the same with the 6. This would be 6 to the 3rd power. So this is our shortcut here. If we're multiplying two numbers and we take that to some power, we can simplify it like this by taking each of those numbers to that power. So in general, our shortcut, if we're multiplying two numbers, let's say smiley face and heart, and we take that to the mth power, we can rewrite that as the first number to the mth times the second number to the mth. In our example, we had 2 times 6 to the 3rd power, and we rewrote that as 2 to the 3rd times 6 to the 3rd. Let's try another example. Let's say we have 3 times 8, and we take that to the 3rd power. We can think about this as multiplying 3 times 8 3 times, or using our shortcut, we could go straight to 3 to the 3rd times 8 to the 3rd. Now let's try a couple examples using the different shortcuts we've learned. Simplify. 7 times 7 squared times 6 to the 3rd to the 3rd power. In this case, the word simplify means rewrite using exponents and as few symbols as you can. So essentially, we want to rewrite this in a shorter form. So looking at our 7, we can consider that as 7 to the 1st power, and our 6 to the 3rd power, we can rewrite as 6 to the 3 times 3. Remember, when we have an exponent and then we raise that to another exponent, we can just multiply those. Now we're multiplying here with the same base, so we just add the exponents. So we'd have 7 to the 1 plus 2, and then 3 times 3 is 9, and we can simplify. 1 plus 2 is 3, so we have 7 to the 3rd power times 6 to the 9th power. So we took the original expression, and now we've condensed it into a shorter form. All right, let's try one more example. Simplify 3 squared times 4 squared times 3 to the third, and all of this is squared. Okay, let's break this down step by step. PEMDAS would tell us to start with what's inside the parentheses, and we have some multiplication. Since we can multiply numbers in any order, let's group the 3's together. So we'll have 3 squared times 3 to the third times 4 squared. So right now we're just focusing on parentheses. We can simplify the inside further. Since we have multiplication with the same base, we can add the exponents. So we have 3 to the 2 plus 3, which is 5, and everything else stays the same. Now we've simplified the part inside, so how do we deal with that square on the outside? Well, if we represent our 3 to the 5th with a smiley face, and represent our 4 squared with a heart, we can use one of our shortcuts. If we multiply two numbers and square them, we can rewrite this as smiley face squared times heart squared. And what did our smiley face represent? That was 3 to the 5th, so we'll substitute that back in. And then our heart was 4 squared. So we're just making a substitution, replacing our smiley face and heart with the actual numbers. Now we have 3 to the 5th to the second power, so we can rewrite that as 3 to the 5 times 2. Similarly, 4 squared to the second power, we can write as 4 to the 2 times 2. This becomes 3 to the 10th power times 4 to the 4th power. And we can simplify this further. You might notice that 4 is the same as 2 squared. So we can rewrite this piece. Now we have 2 squared to the 4th power, which we can rewrite as 2 to the 2 times 4. And now our final answer would be 3 to the 10th times 2 to the 8th. So we took the messy expression from before and condensed it down to 3 to the 10th times 2 to the 8th.